Hey, John, how are you?
I'm good, thank you. How is it going?
I'm great. Glad to see you. So,
Good to see you too.
thank you. So, I'm really glad that we found a slot in your calendar to make this call and to make this interview about your experience in AI and touch some interesting questions, intriguing questions about AI projects and your experience. So let's start maybe with some simple stuff like what is your position? What do you do? So tell us more about that.
My role at Siemens is to develop business that is related to AI and industrial computing. And the tools that I use and that I have is mostly partnerships, developing partnerships with NVIDIA and NVIDIA ecosystem. Companies that are developing solutions, developing software, different kind of players that all together make AI work on the factory floor.
Thank you. So, um, what is your unique experience and how did you start working with AI? And what's your role within the AI incubator?
I believe that everybody's experience is unique, so I'm not unique in my unique experience. I think what works best and what helps me do the stuff that I do is having a combination of different experiences. In my case, it would be industrial, manufacturing in particular, engineering, software development, integration of complex systems, and business development and doing business in general, entrepreneurship. Altogether allows me to look into customers' problems, customers' expectations, and to find the technology that works. And also to build the solution in a way that um, I minimize the potential risks because almost any project has a risk to be not successful, and you need to know way ahead what may go wrong and to predict it and to compensate for it or maybe choose another path. That's closely connected to how I got into AI. I was not born into AI, and maybe the first experience that was close to AI development was in 2005 when I had my PhD thesis in big data for manufacturing optimization. We didn't call it AI back then, and we didn't call it data science. It was big data and data mining, but it already showed us promising technology. Maybe the limitation back then was that there wasn't enough data, good data to test and to use the models. But yeah, it started almost 20 years ago.
Wow. Well, that's great history. Right. Okay. Thank you. So, and what's your role within the AI incubator?
I coordinate the incubator from the Siemens perspective. Siemens is
Mhm.
a diamond partner, one of the key partners of the incubator. And my role is to move things forward from the Siemens side. We are excited about this initiative. So we love uh, the way how the incubator is organized and conceptualized. So, and Siemens is a very big company. We have over 300,000 people. And we have different business lines, we have different divisions, and moving information and organizing people in the right way so that the incubator works is my top priority at the moment.
Let's talk about maybe more specifically about AI. So, is AI a must have?
You can live without AI, definitely. Uh, I don't think that AI is something that people will not be able to live without, but it shows that there's a lot of stuff that we can make easier with AI. And I would say that if you would like to be competitive, you need to compare yourself to other players on the market. And if they do things more effectively, if they optimize their processes, if they bring down their costs using AI related tools, that means that probably one would also like to look into that, at least to estimate the potential outcomes, the potential effects of using AI in your business processes. So in some sense, you could definitely live on without that, and it's just a tool. Like I often hear AI being compared to electricity and energy. Can you live without electricity? Of course you can. People do that. But will you be effective? Probably not, especially compared to other people and companies that are using this kind of technology.
Yeah, but still, so are there any verticals or maybe type of companies that would not benefit from AI implementations?
I wouldn't divide them by verticals or industries. I think we can outline some key factors that where implementing AI may help more than in other cases. There is a sweet spot. If we AI is a very broad topic, right? So we need to narrow it down here. I will narrow it down to the Siemens's home stadium, the industrial manufacturing automation. And I would say if you have a process that is very rigid and very well described, then probably the traditional automation tools are good enough for automation. And when you start to introduce change to the process or to the product, that's where the traditional rules-based automation may fail, or at least work not as good as with a preset configuration. So, and rules-based traditional automation requires engineers to be configured and tuned up, calibrated at least. And with AI, we have more margin for variability. And so in general, I would say if the process and or product are more variable than not, then it's probably that AI may be better applicable. And there's always like a limit to that. So if the process is very variable and very hard to, if it's very inconsistent, then probably people would do the job better than AI or traditional automation. So the sweet spot of AI is between the traditional automation and human work, human operations. That's where it works best. So if the industry is in this sweet spot, that probably AI will make sense business-wise. And on the extreme parts of this spectrum, I would say that we need to make a deeper look before we make any decisions.
What was the most challenging project you've been involved in?
I would say that any AI project that is expected to give results in the real world is challenging. The more real world feedback, real world actions are required from the AI inference, the more complex it becomes. So I think Elon Musk said that nothing is more complex than the real world. I may not bring his quote accurately, but the idea is that in the real world, there is always something different than what you have observed earlier. And what we call AI is basically deep learning tools. And they are based on data. So if the data that you have at your training does represent the object of that you're trying to automate, then most probably you have good chances to make a production system. For me, we had a couple of industrial projects, mostly in computer vision, that were connected to high speed, high variability, high noise level. And noise in this context would be anything that doesn't have signal. So it can be noise because of some vibrations, your image becomes less stable. It can be water drops, It can be whatever, steam, dirt, everything that makes your signal less pronounced in the data. So yeah, I don't think I can name the exact customer, but it was related to food and beverage, and it was seemingly simple task in the beginning to look for wrinkles on packaging, and in the real environment, it became a pretty much significant challenge, especially when you needed to do it with latency, with low latency, so that you can react to the defects found in a timely manner, be able to stop the line or to do some other corrective actions. And it's getting
Yeah.
simpler, I believe. Delivering projects in AI, the way how we did it 4 or 5 years ago, the amount of research,
Mhm.
amount of trial and error was definitely higher than what we do today, because the tools have developed significantly, the models have developed. We have more compute power. Every 2 years, NVIDIA introduces new GPUs. I heard that they are switching to having new models every year. So you always have more powerful equipment, and more experience, and more pre-trained models, well-established frameworks as you move on. But yeah, nowadays it's easier. It's like with automobiles, right? So the amount of actions you needed to do when you started a car 100 years ago from now, and what you need to do now, just
Let's talk about difficulties. So, what are the main reasons for AI implementation failures?
I would divide it in two categories. One would be business and another one would be technical. And for the business perspective, you should always look for a good business case. I think it's applicable not only for AI, it's for any kind of project that you have in your business. But with AI, the thing is that you need to do a significant amount of tests before you can consider that your system is ready for production. So it all takes some effort and some resources. So you need to choose wisely. And if you don't have a strong business case, there is a higher chance that you will not get enough support to bring the project to its production phase. So look at the business case first. And the technology is pretty well advanced at the moment. So my rough estimation would be that 90% of all ideas that you may come up with, they can be implemented if it makes sense. So the technology is not the hardest part. The business is still the hardest part. And you need to calculate the business case correctly. So not always we see that companies are doing that right off the bat correctly. There are a lot of factors involved. So yeah, it starts with counting money and it ends with counting money.
And this is the main reason why many projects fail, right?
I would say from the perspective of business, what means failing here? Failing means that you did not get the business effect that you would be satisfied with, right? So in some cases, it's just you did not go all the way and you decided to stop the project before it was able to deliver the results. And usually companies do that because they don't see it right away, the right effect right away. And usually it works in the way that the initial phases of the project may be successful, and then when you start to scale, it may become worse. So you need to know early on what challenges are you're going to face at the scaling phase, and
Mhm.
engineer your solution from that perspective, not just trying to prove that the technology works with just one case of some isolated environment. So you need to consider variability early on. Variability is the biggest thing. So if I would choose only one word to name the reason for project failure, it would be variability.
And what was the most successful or satisfying project that you've done?
I think, again, satisfaction may come from just solving the problem, the technical problem. It's not necessarily connected to business. But if we look from the business perspective, that means that you are able to save or make money for the business with the solution that you do. So it is not necessarily the most complex and sophisticated technology. Sometimes the simpler stuff works well and brings money. And that's where I believe the sweet spot is. It's not in the very complex state-of-the-art technology that requires additional effort, I would say indefinite effort in bringing it to production. But it's more based on some mature solutions that work well. For example, NVIDIA has a bunch of pre-trained models for people detection, recognizing gestures, people moving, license plate recognition, vehicle identification, this kind of thing. If you find a good business case for that, that's way easier and safer to implement than go into science. Also, I believe in language technologies. I like what's happening with large language models, and knowledge management is one of the very promising areas. Every company has a huge amount of technical data, and no human being is able to grasp it all, especially given the informational environment that we are soaking in. You have a lot of noise around, so it's hard to concentrate and get the right stuff, and that's where LLMs help. So I believe in LLMs and their business application as well.
What can be the right measures and how to measure the outcomes of an AI project?
For the majority of cases, that's your ROI, return on investment, the amount of money you get in return of the resources spent. So I still believe that money is the best indicator of project success. If you're able to make or save money, that's a measure of how well you are doing with AI. At the same time, not all the companies are expecting immediate return. So some of them are investing in long-term research, and that also makes sense. But for the majority of companies, I would say that just evaluate the return on investment. The key thing here is to calculate it correctly. It can be in defect reduction, losses reduction. It can be in reducing the manual labor. Depends on what the key driver for the company spending is. That would be the objective function.
So, and what's happening in their AI talent market? Is it hot? Is it real?
I think, as in any, AI is a hot topic, right? It was a hot topic, and it's not boring. And so the thing is that it's changing as well. So it's not just something linear that is moving and just on the same path. We have black swans, I think, almost every year, and the famous ChatGPT introduction and the role that it plays now in everyday work of people. So it also changes the people that are building AI are different from what we had earlier. Several years ago, these were mostly scientists, right? Nerds. And nowadays, those nerds, they were working on building new architectures, new models, new technology. And nowadays, we have this technology available almost for anyone. So it's not the bottleneck. And the bottleneck now is mostly data. So being able to obtain and process the right data is the key success for AI implementation. So we need more people that are able to work with data, not necessarily mathematicians that are coming up with new concepts and new theories and new models, but people who are able to work with huge amounts of data and process it, understand how to get it, how to generate it. Also subject matter experts, people who know how the processes work. For example, for industrial applications, you need to know how the process works normally, what influences your manufacturing, and what are the bottlenecks, where are those key points where you could improve things significantly, where you lose a lot of money, or where you tried and failed to automate with the earlier kinds of technology. So I would name these two as probably the emerging. It's not that they are new, those functions, but nowadays they are more needed than earlier because the rest is easier to implement than it was several years ago.
Got it. So, like data engineers, right? So
Yeah.
how would you call those roles, right?
Yeah, data engineers and people who understand the subject matter and who understand some of AI so that they are able to merge those two worlds together.
So how can the educational system keep up with this pace of the progress?
I believe that education is a personal responsibility of each individual. So you cannot be taught, you can only learn things yourself. And the key factor here is willing to learn, being open to solutions. And the key driver for that would be to face the problems first, not to get the solutions first and then try to find the problems for them, but to get into the subject matter, let's say manufacturing or logistics or whatever it is, and try to solve the problems, fail, and then learn how it might be solved with AI or some other technology. And this way, when you see the solution, you would learn it way faster and with greater interest and self motivation than the other way. So yeah, I believe that you should go face the problems first, try to solve them.
Let's talk about hardware. AI is expensive, and some companies might see that as another marketing campaign to sell more costly vendors' equipment. So, what do you think about that?
I believe you should always look at the money, at the bottom line. If you're able to save money or if you're able to earn money, then the cost of the equipment or any other technology or software frameworks is just a part of your model that you build to estimate the feasibility of the project. So I wouldn't say that AI is necessarily expensive. Again, there is a spectrum. You have well-established, repeatable solutions that are pretty inexpensive. You can actually, they are free. You can download a pre-trained model and you can build your simple solution yourself without paying anything to anyone. You need to spend for equipment, but it's not. Equipment gets more and more. The performance of the equipment quadruples, or I don't know what's the factor, but 4, 5, 10 times each new model is more effective than the previous one. So you can do more with the less equipment than you did 3 years ago. So again, the limiting factor would be to find the right problem to solve first. And if you see the problem, then you are able to estimate the effect of this problem and the potential business effect if you solve it. That's the key thing. And again, the cost of the equipment or some software will be just a part of the equation.
Yeah, agreed.
But it can get very expensive if you do not foresee what can go wrong. It may become a bottomless pit where you bury your money. So yeah, it's better. Best thing to have is to have experience. If you don't have experience, it's better to ask someone or maybe have them on your team. So someone who has already tried and failed and succeeded and failed again. That's probably the most valuable thing.
Yeah, all right. And what's the average reasonable budget for an AI project?
Again, AI is a very broad thing. It can be, it's like with electricity. What's the average budget for an electrical project, right? So you can have a light bulb and you can build a nuclear power plant. I would say that it's easier when you have some simple bricks that you can build your solution with. For industrial application, I would say that a proof of concept can be done starting with $0. You can just get something open source or readily available and just try it. There is a lot of offers for trial use of different technology. But if you would like to do it with someone else's hands and minds, that would be probably $20,000-$30,000, I would say, for a POC. If you do it yourself and you just use someone else's service for more detailed work. And I've seen different projects. Some of them are in hundreds, thousands of dollars. Usually that is more customized when you have something more complex engineering. And actually, my belief is that if you have a complex case that has a strong business case, and usually you need to combine several parts together. That would be AI part, data science part. It would be integration part when you bring together and build a solution consisting of different systems, hardware, software, sensors, and you have the motion control or some other feedback processing part. So you need to not just to sense what's happening in your process, but also to react somehow. So binding these all things together is usually takes more than just one company. You may have 2, 3, 4 companies involved there, maybe more if you include the hardware vendors. So the key skill here is to coordinate these combinations of technologies. I forgot what was the question actually. I read my favorite topic of business cases, and
question was about the budgets, and you mentioned that something can be done free, something some help may require some investment, and you've seen projects, bigger projects in 100,000. Yeah. So what are the factors impacting this investment?
I would say you don't have to spend it all at once. So you don't have to dive into huge expense at first. It's good to understand where is the highest risk for the implementation of the project, what is available with the technology that is already on the market, and how your own case is different from what was already implemented. And check this hypothesis first, the difference, your special thing. Check how the readily available systems work with that. So you can plan your spending here, not spend everything on a complex solution. So yeah, I would say it's from tens of thousands to hundreds of thousands for an industrial solution. Production scaling would be more expensive. It goes to millions at this moment. I don't think that you can do in 2023 at least to do a complex custom system that would scale. It will be 7-digit budget.
Would you name 3 AI projects that you'd like to maybe participate in or replicate in the AI incubator?
I would probably outline the general concepts. The first would be computer vision. And I like how the effect it can have with computer vision, high speed, high variability process with a very strong business case. Like some company is losing a lot of money because this problem is not solved. That's what I would like to work on with computer vision. The second would be connected and knowledge management. And I'm yet to identify the exact problem here, but it will be connected to huge amounts of information where you just need to bring a simple answer without having internet connection. And for example, to help a technician or some engineer to solve the problem on site without having to run through hundreds of pages of information just to have it on at their fingerprints. And the third would be, I believe, in audio and acoustics and some time series signal to identify the potential faults and problems. And I would be interested in this kind of, you can say it's predictive maintenance or some early detection of potential faults, maybe at sub-millisecond level. So to be able to react quickly to the things that didn't happen yet, but only are emerging. So that would be probably the most interesting thing. Sub-millisecond range is very interesting. Low latencies. It's a very challenging problem, but if you can solve it with complex data, that can help a lot of businesses and industrial processes.
Yeah, that sounds amazing. Thank you, German, for the call and for your answers. So that's a very interesting and deep dive. So very unique perspective. Thank you for your time, and
thank you so much. Thanks for having me.
Stay tuned. Thanks. Bye.
It's fun. Thanks. Yeah.